Respected everyone, myself A. Igneshwari and our teammates are Avinash Reddy Bhavanam, Konika Das, B. Pavanse. And we are from batch number 8. Our project title is Development of Automatic Drip Irrigation System through Cloud Monitoring and Web of Things Technology. Our project guide is Mr. K. Pavani Madam. Before going to our abstract, the agriculture is one of the best economy in our country. But at present, lot of farmers facing many problems like due to scarcity of water and an irregular power supply. In some areas, there is a lot of scarcity of water. So at that time, some farmers can hire a people among them and some may not hire a people. The people who are hiring can afford to farm their own land and the people who are not cannot afford or leaving their farming land as empty. The drip irrigation system is one of the main existing system at present in our state which farmers are using. Using this system, there are some drawbacks like it is completely manually operated. A particular person has to release and stop water from pipes. While this process is going on, if there is any loss of power supply, a particular person or manually have to check whether it is completely watered or not. If it is may not or may water, he have to continue the process and repeat the same process again and again. Currently, farmers are burdened a huge amount every year. Similarly, there are also some loss of water as limited and irregular power supply. Of these drawbacks, some farmers who cannot hire people, at the same time some people who cannot afford that much of amount every year, similarly stopping their farming. Here, our idea is proposed to automate the existing system, the complete process of water supply in drip irrigation by using Web of Things technology. By using this, we can reduce around 90% of monitoring cost and also have an optimal water usage. It also reduces effort of the farming people. Coming to our address problem, the first major problem is farmers are facing irregular power supply. Due to this, farmers cannot finish their work within a specified time. Constant monitoring. As we discussed before, a particular person have to monitor the specific land is completely watered or not. And finally, a manual operation.
While surveying for this project, we found that none of the solutions existing in India use Internet of Things, and there are no completely automatic solutions. To reduce the workload on farmers, irrigation timers have been implemented. These irrigation timers can be set to operate automatically, that is, switch on and switch off the valves automatically for a specific period of time. These valves also have to be set manually, which also requires a lot of work. Plus, these timers are not reliable during power cuts, especially in rural areas where power cuts are very frequent and power supply is irregular. There have been cases in which during power outages, these timers have been found to reset automatically without any notification. Hence, this is a non-reliable solution. Another solution that we found is the use of soil moisture sensors to check the moisture content of the soil and then switch on and switch off the water supply automatically. But in case of drip irrigation, these moisture sensors have to be placed at every plant. This increases the number of sensors, hence increasing the cost. And also it causes convenience during plowing the field.
Our proposed solution is, firstly, we are making the existing system to be automated. By making this, we can completely avoid the manual operation so that there is no need to hire people and no need to maintain a particular person to be checked. Controlling using smartphone using IoT applications. Finally, with this feature, a farmer can operate his particular existing system anywhere to his farming land. Automatic operating system based on weather. With this feature, the system will completely work according to the weather conditions. Means if it is rainy or cloudy at outside, the system will stop operating. So with this feature, we can save huge water. controlling using smartphone using IoT applications. Finally, with this feature, a farmer can operate his particular existing system anywhere to his farming land.
Okay, this is a block diagram of our project. So this block diagram consists of a node MCU module, a three-phase detector circuit, and a driver circuit, and also DC motor with geared wheels and the valve. So basically here, so the on the field section, like in the field, so to control the valves on and off, like to make the valve in to change the valve from on state to off state or off state to on state. So we are going to perform this operation with the help of a DC motor attached with a gear wheel. So here the DC motor is controlled by with the help of the microcontroller module by driver circuit. So here the importance of driver circuit is to power up the DC motors with the required amount of power. So like the microcontroller operates at low power ratings, approximately 1 watt around. But when it comes to the DC motors, they operate at minimum amount of like 6 to 12 watts of power supply rating. So for that purpose we are using here the driver circuits. And when it comes to the microcontroller section, so here we are using node MCU module. So why we are choosing this module? So like in our project, our main motto is to control the to operate the walls with the help of an Android application through internet. So for that purpose, the hardware circuit must be connected to the internet server. So to the server through internet. So for that, we need an Wi-Fi module. So we are using here a Wi-Fi protocol. So we need a Wi-Fi module. So here Node MCU comes with an onboard integrated Wi-Fi module, which is a bit easier. So when it comes to other microcontroller modules, we want to integrate it separately the Wi-Fi module with the hardware section. So that's why we opted for this Node MCU module. And also, so the three-phase detector circuit. So the three-phase detector circuit functions. So it detects the power supply, like the motors are basically on the fields are operated with three-phase supply. So if one phase is failed, then the motor stops working. So to predict this, whether the power supply is in a correct format or not, or like three phases are activated or not, so we can detect with the help of this three-phase supply. So and also a 5 volt supply to power up the microcontroller, and also 12 volt supply to power up the DC motors are also used. So all these are diagrammatically represented on this block diagram, and you can see these blocks etc. This diagram completely by pausing this video. So this is the circuit diagram of our project. So in this circuit diagram, so I'm going to explain in detail how it works. So here the first part of the circuit is three-phase detector. So the three-phase detector, so which is used to detect the three-phase supply. So for this purpose, I am using three bridge rectifiers. So each one is connected to single phase, like one phase, like out of three phases, each rectifier is connected to single phase individually. So that means, so each and every rectifier rectifies a 230 volts AC and gives a 5 volts DC output, and these phases are compared with the help of an AND gate IC. So that is 7408 IC. So here the three phases are compared, and if the output is high, that means if three phases are high, then that indicates that the supply is on. If any phase is failed, then the output of the AND gate is 0. So this feedback is used to identify whether the power cut condition is occurred or not. And here we are using a node MCU module which is belongs to ESP family. So here we are using ESP8266 Wi-Fi module. So it consists of 30 pins and it operates on 5 to 3.3 to 5 volts operating voltage. And here it consists an onboard regulator, voltage regulator, so which is used to decrease the 5 volts supply to 3.3 volts also. And also it comes with a 3.3 volts output also. So we are like with the help of this supply we can attach some more modules which operates on 3.3 volts without using separate power supply also. And 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 comes to the driver circuits. Here we are going to use the driver circuits are DRV8848. These are made by Texas Instruments, and these are the H pitch rectifiers, like H pitch drivers. So each driver can drive two motors and it can bear up to 18 volts also, and like 18 volts also. When it comes to the motors, so here we are using a 12 volts 10 rpm DC motors. So for our prototype, it's we are using 1.5 kg torque motors, so which is pretty much enough. But when it comes to the and higher applications like 2 inches walls, etc., etc., so then we are going to 4.5 kg torque also. So these are the components used in the circuit diagram also, and you can pause the video and you can detailedly observe these components on the circuit diagram.
Advantages. This depreciation system is a one-time investment, and it reduces the cost of 90% for a daily monitoring person. If a person monitors daily, it charges 300 rupees for daily. It takes every day he comes and monitors. So the cost of the person is less than the cost of our project. Our and it don't you no need to monitor it daily daily for a person to come and check whether the form is water or not. It is also an automatic system, so the landowner can only invest one time, and the uh, only invest one time, and cost of the cost of the labor also decreases. And also it increases the use of drip irrigation system in India, and it is a better knowledge of every agriculture person to 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 water the plant daily. Applications. It is used in agriculture fields and nurseries, and agriculture fields, nurseries, and garden areas too, where the plant wants the water, where we are going to water the plant. There we use this project.
Also here displayed some of our making progress pictures. You can view here.
To demonstrate this, we have constructed a 5 by 5 square feet field. This is how the prototype looks. We have also designed an app which the farmer can use to control this system. The app consists of two modes, auto and manual. In auto mode, the farmer need not monitor the system. When the power supply is on, this system switches on automatically and turns on and off each valve. In manual mode, the farmer can control the motor and the valves through his phone without actually going to the field.
And finally, coming to our conclusion, we are here with to reduce the burden of farmer, same time automatic the drip irrigation system, and also to introduce IoT technology in Indian agriculture system.
Future scope. So we are planning to extend for future scope, and the future scope was if we are weather based system, and also we are we are preparing to store the data in a cloud. By storing this data, we can know that the farm is watered at which time the farm is watered and which time it has been stopped. And we are also planning with AI, artificial intelligence, for the future extension. Artificial